Okay? Actually, let me do it down here. I bet. I'm not going to have enough space. So let's say we wanted He2, He, He. Now, that's the 1s, and there's supposed to be 2 electrons there, and that's the 1s, and there's going to be 2 electrons there. So what do? At the bottom, we fill a bottom one, which is the bonding and the anti-bonding. Now, we actually have to put names for this, all right? Since this is 1s, we're going to name this 1s, okay? Now, if you remember correctly, this is chapter 11, so we should know what is a sigma and a pi bond. Sigma is the first interaction, pi is the second. Is everybody agree with that? So we're going to call this sigma 1s. And then up here, we're going to call it the sigma star 1s. And the star denotes what? What does the star denote? Antibond. The sigma is just a little upside down V. Okay? Some people write sigma like this. It's like a little circle. I like it like this. Same thing. Okay? So here we go. How many electrons are going to go in? We got 4 on the outside. We're going to pull them all in, right? So we go 1, 2, 3, 4. So you fill the bottom first, and then you go up. So this is what the diagram looks like. And all they want you to do on the test is draw the diagram. Draw the diagram. Draw the diagram. Can we draw the diagram? Probably. All right? I'm pretty sure you can. All right? Now, the good thing is that they're going to give you the order of how
Rich
it
is
goes
fucking
up.
awesome.
So it'll start with sigma
Study
first,
edge.
1s, then what would be the next orbitals? 2s, then the next orbitals would be 2p. All right? So they will tell you that order. It is different for different molecules. Let me repeat that. It is different for different molecules. So if they give you nitrogen, okay, that's different from the oxygen one. So you just got to follow the right order. Okay? That's not a problem. Okay? And I'll show you how to do it. Now, the other thing that they will ask you to do, aside from filling in the diagram, is answer some questions, like the bond order. They might ask you what the bond order is. It's a very simple formula. Bond order equals half times the number of bonding minus the number of anti-bonding. Okay? And the bond order greater than 0 means it is likely to exist. Bond orders of 0 mean the individual elements are more stable than the compound. So, if I had He2, that means what? This is going to be 0. Does everybody get the bond order is going to be 0? Because bonding is 2, anti-bonding is 2, so that's 0. What does that mean? He2 doesn't want to stay like this. It wants to be by itself. That's all that it means. And that should make sense, right? Because this is a noble gas. Why the fuck would you want to come together? But H2, the bond order there is 1. Is everybody good at that? Because H2 wants to come together. All right? So that's what it says there. Now, last thing is, the higher the bond order, the stronger the bond, the more stable. So they might ask you which one is the most stable as well. Okay? So let's do it. Any questions before we begin? Because once I finish this question, everybody runs out. So, no? Make sure you fill out the feedback form. I know it's long. You're like, this is long as fuck. Sorry, I know. You're going to write that down. That's okay. So using the molecular orbital theory, place O2 minus, O2 and O2 1 plus in order of increasing bond energy. The valence MO sequence is this. Yay! Yay! All right? So they give you that. If they didn't give you that, this question would be hard as fuck. All right? Because you got to memorize more shit. All right? So, first of all, they gave you the valence. So that means we're only working with the valence. That's why it starts at what level? What level did it start with here? 2 instead of 1. So that's why we only want the valence. Because oxygen's level, the valence shell is level 2. Okay, good. So let's go ahead and draw out the sequence. It says sigma 2s. So we're going to say sigma 2s at the bottom there. And then I'm going to do what? Sigma star 2s. You do not have to draw things on the side. You just got to draw the middle, because all we care about is the MO, is the center. And then we got the, what else? What's next? Sigma 2px. All right? That doesn't matter. Just means it's x, y, and z, which is what we talked about in quantum numbers, that there are 3 orbitals for the p, x, y, and z. All right? Now, everybody look up, please. The pi, there are always 2 orbitals. they're always going to be equal in energy. Your professors might try to trick you while they just put 1. But you always got to remember, for pi, there are 2 orbitals. Okay, so that's what's next. Pi 2p, pi 2p. After that, pi star 2p, pi star 2p, and sigma star 2p. Any questions on how I drew this thing? No? Okay. O2 1 minus. So we count the number of valence. Now, if you wanted to count all of them, you would have to start at 1s. So you get that, but we want the valence here. So that's going to be 6 times 2 plus 1 more equals 13 electrons. Any questions on how I got the number? Valence. Oxygen is in 6a. The minus 1 means I add 1 more. So everybody look up, please. Here's how we do it. Go 1, 2, 3, 4, 5, 6. I filled in from the bottom up.
Hey, sexy!
7, 8. What rule is that?
Just strip. Just start stripping. I want to see you naked.
7, 8, 9, 10, 11, 12, 13. That's a pretty diagram, if I say so myself. What's up?
I'm still sitting here. That's the shit I don't like.
No. 1, 2, 1, 2. They're the same energy.
Like, at least 20 more minutes.
They're the same energy.
Just chill for 20
Okay,
minutes
they're
and
the same
then we
energy.
party
All good.
straight from
All right.
now
So
till
that's why I
like
say same energy equals.
Monday night when I have my exam.
Same
And screw this
All right.
exam.
So
Screw
now
it.
we can find the bond order.
I want to see your meatballs.
Somebody smells. Now, the bonding is going to be
Oh,
2,
true.
2, 2, 2. So that's 8.
Mosquito net.
Minus the anti-bonding, which is 2.
Sex trap, not
2,
mosquito
1.
net.
That's
Sex
5.
trap. Get it
So
right.
that's 3 halves. Agreed? That's how you find it. So bond order is a little bit different in that case. All right. Now we're gonna do. Let's do the next one here. O2. All right. It's the same one, so I just draw the same fucking thing. I don't have to rewrite the whole thing again. I just be like, I drew that. Okay. I know these are the stars. These are the stars. These are the stars. I don't care what the labeling is because I already did it here. So that's the same one, right? Because they're still what? They're using the same diagram, right? Because they're all oxygen, so they have the same exact diagram. So for O2, it's going to be 6 times 2 equals